Well, then I've also seen that you break some stuff intentionally because you have a video on exploding LEDs.
Yeah. So sometimes like electronics can be fun.
Hello, everyone, and welcome to the Altium OnTrack podcast. I am your host, Zach Peterson, and I'm happy to be sitting down today with Bill Kolicoski, founder of the Taste the Code YouTube channel. This should be a very fun talk, and if you haven't seen the Taste the Code YouTube channel, we'll have a link in the show notes. And with that, let's go ahead and get started. Bill, thank you so much for being with us today.
Hey Zach, it's a pleasure to be here and thank you for inviting me.
Yeah, absolutely. Looking at your, at least the title of your channel, I think when someone sees Taste the Code, they're going to think, this is like a coding channel, maybe some coding tutorials, things like this. How did you get started doing YouTube videos and, what is your background?
Well, I'm primarily a software developer, so I've started writing software about 12, 13 years ago, and I've always had a passion for electronics. So because I was working on something else, I wanted to uh, I don't know, start something as a hobby where I can just join the two passions together. And that's how Taste the Code got to be. And um, the idea behind the channel is that I can build something with code that also has something else inside that can then let you to taste how that code can interact with the environment. And electronics was the perfect choice to build such devices where you can have code interacting with electronics and doing stuff that you can then actually see, like turning on the lights or controlling temperature somewhere that you are not present in, and it gives the taste to the actual code that runs somewhere in the background.
So it's almost a play on words to make the code more tangible, if you will.
Yes, definitely. Because when I started working as a software developer, the uh, the problem that I have seen people had with software is that they weren't understanding how the code works up to a certain period in time where they actually got better at using that code. Because I think that most of the people, when they start software and software development, they just jump straight through the examples, and that is not always tangible. Like, okay, I can see the result, but I'm not really sure how the whole thing operates, and that's why when we have the two combined, then I think that we can build a platform, let's say, that it gives them something tangible, something that they can play with and see it interactive instead of just seeing results and numbers, or like um, these days is a lot easier uh, to get started and kind of have your fingers at using different UIs. But if we recall in the time, like code was something that you only see through a console, through a terminal, and it was really difficult to be interacted with.
So, what would you say is your mission with the channel? Because I see a lot of very interesting videos with like repair. I see things with what looks like prototyping. I see things with Arduino. You even have a video called Infinite Breadboards, which looks pretty fun. What is your mission with the channel, and what do you hope to convey to the audience?
Yeah, so my main mission is that I want to present the electronics world as something that is really accessible, something that everyone can literally just jump right in it and start learning stuff, because it's really easy nowadays. Um, and I have a feeling that many people have a passion for, like, they admire electronics, but they just consider it as a black box. Like, that's something that we don't really touch, or we don't really. it just works. And I try to basically demystify that it's not that difficult, it's not that complicated. uh, you just need to follow some simple rules and, like, stay safe wherever you are not confident in doing, and just go for it and just enjoy the process of learning by doing, basically.
Yeah, I would definitely agree with you, especially how you said that I think sometimes electronic devices look kind of like a black box. I think it's one of those things that everybody knows is important, but it's almost seen like lesser than software. And yet, none of the software that we get to play with in the tech world would be possible without any of the chips or circuit boards or anything else that happens with the actual hardware. And so it always gets looked over. In fact, here in the US, when someone says like tech company, what are they referring to? Well, they're probably referring to like a big software company like, Facebook or Amazon or something like this. They're never referring to like, Marvel Semiconductor or like TTM, who's a big, PCB manufacturer or somebody like this. So they're always referring to like a software company. So I think that just illustrates how, the general public totally misses the importance of electronics sometimes.
Definitely. Like, I mean, you would not have apps if you didn't have the tech that's inside the phone that makes the platform where that app can run. Or you would not have a website if there is no server that website runs, and infrastructure that it communicates, like, on the physical network. So yes, you are completely correct when you say that many people don't really understand what they are working with, and just consider the whole thing as a black box or a mystery box that somehow miraculously knows how to do stuff. And I think that that's one of the reasons why many people, at least in my area, like, I know I can say 10 to 1 people that work in software compared to people that work in hardware. And one of the ideas that I want to relay with the channel is that it doesn't have to be that way. That the two things can really uh, that the two things really coexist, and they should be treated as such, at least to some levels. Because even though if someone works as me, like, commercially entirely in software, everyone needs to have the understanding of the hardware and how the entire thing operates.
Yeah, I think if you're a design firm, maybe you're a service bureau, if you're a smaller company, maybe you're just doing schematics, maybe you're just doing layout. But like as your company grows in size and the projects that you take on grow in complexity, you start to have to do these other things like software, like firmware, whatever it may be, in order to create an actual product. Because at the end of the day, the electronics is not just the board, it's something that's fully assembled, goes into an enclosure, and then hopefully gets shipped out and appears on the shelf somewhere. Maybe it's just a prototype, but still, there's this interface with the actual code that people have to understand. And my opinion has been that a good way to get kids and students to care about electronics and pursue it as a career has been to approach it, as a software person, but taking like all of the software and making it a bit more tangible for people. I mean, what do you think about that?
Well, it's definitely a mixture of both, because uh, allowing kids to, like, wire up a circuit and just turn an LED with a switch is like the one side of the whole thing. But then allowing them to maybe write a couple of lines of code that they can make it turn, on an interval, it adds just like a different dimension to the whole thing, where, okay, now it opens an entirely new world of possibilities, where they can now consider a lot more than instead of just using the hardware.
Yeah, I think the what you're describing there with, adding layers of complexity in the application and then eventually in the hardware, I think it's great for students to start there because they start to have like what I like to call the eureka moments, the oh my gosh, it actually works, kind of moments, even though it's something simple. I think those moments are very powerful because they show like, oh, I can actually do this. I'm starting to understand how it actually works. And, it really cements that bond that you're talking about between, what happens in the code and then what has to happen on the circuit board and in the chips to make this whole thing come to life.
Yeah, exactly, exactly. That's why I think that the good mixture of both is really essential to not just improve your learning experience, but also improve the outcome of what you can do, and then the outcome of your further of your future ideas. Because once a project is done, then it leaves a lot of questions, like what if I can change this, and what if I can add this, and what if I can maybe just flip things around, and you come to ideas that you've basically never even considered before. And that's something that I really enjoy, and that's definitely a lot of my ideas come from that thinking. Once a project is done, then okay, how we can improve this, and how we can change this, and how we can make it better.
Yeah, that ability to re-engineer it once it's finished, I mean, that's when you really cement the understanding of the device. I think that same skill is really important once you start to look at something like a reference design. And if you're, I mean, I'm semi a fan of reference designs for hardware development, at least just to see how something is wired up and then kind of reverse engineer it for yourself. I know a lot of people that can get in trouble using reference designs, and I've even been burned by, incorrect footprints in reference designs and things like that. But I'm still kind of a fan of them for that reason. But, being able to, I think, reverse engineer it is really that next level of understanding, and really shows that you do really understand this, and you can take this and mold it and get it into that next thing that you want to create.
Yeah, and that reference design is basically the basis of the repair path that I usually take with some of the electronics, because like I don't want things to get thrown away, because especially electronic stuff, because I know that usually it's just a single part that's failed inside, and comparing, finding out the chips inside, and finding out the data sheet, finding out the reference design, and then working around that to see like what the manufacturer did, or add to that, or how it customized. It makes the whole thing more understandable and more approachable, to then start working on it, and possibly repair it.
Yeah, because I noticed you have a few things here, or a few videos on your channel, looking at how to repair something. Um, Looking at, I think you have like power supply repair, and then I even saw impact drill repair, which I'm gonna be honest, like I like to build stuff, but when I go through a drill, man, it's going in the garbage. Like I'm getting a new one, you know. So, how do you pick something like to show for a repair type of tutorial, and what's your approach to debugging something that is broken, and making it into a cool video that's really not just fun to watch, but also educational.
Yeah, so basically the ideas for the repairs, usually I don't pick them, but they pick me. It's stuff that usually belongs either to me or some of my friends. And when something gets broken, they call me and they say, "Okay, I have this device that it's no longer work. Do you want to explore it?" Because that people know that I have interest in such stuff. And like I don't always choose to, it again, if if I choose to have it on the channel, it needs to be a device that probably has something more than just a broken wire, because that doesn't make an interesting video. So like things like repairing a power supply, it's usually either some fuses are blown or capacitors leaked, or um, depending on what the background story of that power supply is, then I'll choose to maybe look into it and then just try to understand the schematic and the whole design on video, and like explain during the video, explain my process of uh, investigating the circuit, so we can know um, what we can focus on and try to understand what's broken.
Well, then I've also seen that you break some stuff intentionally because you have a video on exploding LEDs.
Yeah, so sometimes like electronics can be fun. uh, like a lot of people on YouTube have done exploding capacitors, because that's like a feature that capacitors have. But LEDs are something different, and like they also have some like the chemistry element to them, because not all LEDs are made the same way with different materials used in the colors. So, and it's uh, they make like good indicators, and trying to show people that what LEDs are used for, and like I wanted to show how they can fail in electronics. That's why uh, I showed the exploding LED when you connect it to main voltage. But again, it's not all of the LEDs that explode. Usually, the manufacturing these days is made to such level that all of the components will fail like in a controlled manner, so they won't really just spontaneously explode. It's like one of 10 or one of 20 LEDs that will do that, but that's again in an environment that's really atypical for an LED.
Well, I will say I have had fun burning up 10 ohm resistors from time to time, so I get what you're saying.
It's an addition to just using components. To really understand the component, you sometimes have to abuse it, so to know its limits.
Yeah, totally agree. I think after you burn up your first, set of resistors or LEDs or whatever else, hopefully you learn from the mistake and it'll be the last time.
Yeah, because usually the first one is by accident. Uh, so you make a mistake, you wire something wrong incorrectly, or you are wrong on the calculation in terms of the values that you can use, and then you go back in like trying to understand what happened. And I think that that's the eureka moment that you can have, that only then you understand, okay, that's why that thing burned. And you can really learn going in the future, you can really learn what the limit and what you need to consider in your designs.
Yeah, absolutely agree. So I want to switch gears just a little bit because, well, and I want to ask you directly because you clearly, know how to do this stuff with hardware development. But I believe you mentioned you working full time as a software developer. So what made you pursue software as a career instead of pursuing hardware design or hardware development as a career?
Well, originally I studied applied computer science, so we kind of got into a lot of different areas. It wasn't really dedicated to software or to hardware. And at the time, designing PCBs happened with the like just the bare PCB, where you actually draw the tracks and you etch it in chemicals, and um, it had a bit more like barrier to entry compared to software. And because I'm based in Macedonia, which is like not in the European Union. So we used to get offers a lot where we could outsource and work for companies that were abroad, and software was much easier to be like outsourced, and it had a lot less barrier to entry, and it just kind of happened. I would say it's not that I specifically chose software. It's kind of like it naturally happened to be.
I can understand that. I think for a lot of students, when they are considering a career in technology, I think if, at least in the United States, when you look at what the opportunities are, and especially when you hear about, crazy software developer salaries in like Silicon Valley, it's very tempting to pursue software as a career because there is such high potential for payoff, even though the barrier to entry can be quite low. So I totally understand what you're saying, but it sounds like there's maybe a different set of challenges to you being where you're located in Macedonia, because maybe there's not the same type of resources for pursuing hardware development as a career, or for access to equipment or whatever it may be. I mean, is that maybe a bit more of the challenge for someone who's in your position in Macedonia or in that region?
Um, for sure it is, because up until recently, like there wasn't anywhere where you can build like commercial grade PCBs or commercial grade electronics other than just the PCBs that you can build at home, or maybe some basic amplifiers, or like basic TV gun type of circuits and devices that you can build at home. But nowadays, I think that that's greatly changed, because uh, the availability of custom PCB design choices and manufacturing possibilities that we currently have, where you can order stuff online and have it in just a couple of days. I think that levels out the field for a lot of people, because it doesn't cost a lot to get started. It doesn't cost a lot to make a mistake and redo the whole design iteration once again. But it's definitely a little bit harder, I would say, compared to software, because in software you can just like delete and rewrite the same thing immediately without waiting for manufacturing to happen, and deliveries and such and stuff. So, but it's definitely changed and improved over the years, and I think that with this wave of people getting interested in PCB design and in electronics, I think we'll see more and more um, uh, like prototypes and people getting into the hobby and into the profession after that.
Yes, I think I agree with you. I think that, on some level, that ability to, send your Gerbers to JLC or whichever other, PCB company overseas is very useful, especially if you're just getting started, and just trying to learn, like, how do you go through this process to make a physical device that does something interesting. Um, and I think with between open source software, just again to get started and learn, and then maybe channels like yours and some other people that we've had on the podcast to get kind of those resources and get project ideas. I agree with you. It's a great way to get started and maybe build that first thing, and it's okay if you mess up, and go back and do it again, see where you messed up. So I think what people like you are doing is actually very, very useful and very important for that next generation of designers. Because here, at least here in the US, we have a big workforce shortage on the horizon. There aren't a lot of younger people my age to replace the previous generation that's retiring. And so I think we got to do whatever we can to get the next generation interested in electronics, and to make it easy for them to have fun doing it.
Yes, definitely. That's the key part. Having fun doing it is something that really triggers a lot of people to pursue something. Because if it's just a job, it can be anything. It doesn't have to be like electronics or even software. It has to be something fun, so you make someone interested in pursuing something like that.
Absolutely agree. Yeah, I absolutely agree. Um, so with that in mind, where does someone in your position go to get interesting or, useful resources to keep expanding your skills? And if someone is a hobbyist and wants to, transition from just doing it themselves to actually, doing this as a job, whether as a freelancer or for a large company, how do they make that transition into a professional designer? Because I have my own opinions and resources that I use, but you're coming at this from a bit of a different angle, starting as a software person, and then kind of bridging those skills into hardware development. So how does someone follow along that path and do it successfully?
Well, for me personally, I like to get my hands dirty immediately. So I just jump into the schematic and into the PCB and the design process. And at the beginning, I had a lot of challenges where not knowing the software, not knowing Altium made me a bit hesitant to even try it. But then I said, like, what's the worst that can happen? Like, I mean, I already don't know how to do this stuff. The only thing that can happen is either I continue not knowing or I learn it just by doing. And for me, uh, I just like Google a lot of stuff or try to find YouTube videos with specific problems that I'm currently having or specific challenges that I'm trying to resolve, and that's how I basically grew from being like not knowing anything about PCB design and PCB design software to like building at least several successful prototypes where I've built the board, I've ordered it, it got manufactured, and it successfully worked. For people to be able to continue this as a profession, I think that they will uh, they, they will need to basically invest a little bit more time than just figuring out few prototypes. And even for people that didn't have a degree in PCB manufacturing, I think that they can still learn it easily if they dedicate enough time to it, and if they kind of start building stuff, start designing the stuff, and then a huge help I think will be for them to make their work public. I know that that sounds scary at the beginning, but in the end, I think it's well worth it because that way you can get feedback from the rest of the community, from the rest of the people that actually do that for a living, and that would make you a better designer and a better. You can be better in basically whatever you decide to do on if you choose to make your work public.
Yeah, it's always very valuable to have those resources available where you can ask questions, get feedback, get tips on how to maybe make your design even just look more professional. I would totally agree with you. Making your design is public, or going to a forum where maybe it is a bit more public, like Stack Exchange is one of my favorite resources to look at and just either get questions answered, or you can sometimes find your same question on Stack Exchange and find the answer that you need. So yeah, I agree with you. Maybe making your design public or not being afraid to, even if it's pseudonymous, show elements of what you've created to try and get answers and learn and improve your skills. I mean, do you ever do any of that? Do you go onto forums or anything like that to get questions answered and try and expand your knowledge a bit?
Yeah, definitely. I mean, I use forums constantly. So, and as you said, a lot of times, like in maybe more than 90% of the times, you will find your exact question already answered or your exact problem, but with a slight twist already resolved, and you can basically take that knowledge and apply it to your circumstances, and that usually works. But sometimes it's either a weird situation of like things that you have in your current project that make the question unique, and um, I think it's really beneficial if people are just going and asking, because as like many say, there is no stupid question. And you just happen to be in that situation, and there is nothing wrong that you can go and ask it publicly. Um, from my experience, like from what I've seen on forums, people are generally helpful, even though the common, I would say, misconception is that it's not like that. But I've seen just encouragements and like people trying to honestly help you with whatever problem that you might have.
Yeah, I have been on forums a few times, and I think one of the takeaways from going onto a forum and asking those questions is it's not always to just get your question answered for you, but it's even to learn how to pursue getting to the answer. It's almost like the act of talking through the design problem and trying to articulate it really actually helps you figure out how to keep searching for the answer. So it's like, figuring out what you actually don't know so you can dig deeper and continue learning.
Yeah, that sounds a lot like what we have in software that we call rubber duck debugging, where you're actually trying to explain your code to a rubber duck. And in the process of trying to explain the code to someone else, you actually explain it to yourself, and then you figure out, oh, but that you meant to do one thing, but the actual code does another thing. And I think that can be uh, equivalently applied to electronics and PCBs and design as well, because you sometimes thought of doing something differently, but instead you made a mistake and you connected it some to to something else, and it can show you your problem if you just try to go into the act of explaining what you're trying to achieve.
So all those times when I'm talking to myself in my office and trying to talk through a design problem, I'm actually doing rubber duck debugging.
Yeah.
Well, I'm glad I learned what that is because now I'm going to start using that with coworkers and everything. So, thank you so much for joining us. This has been a great conversation, and I really do hope everyone that's listening will check out the Taste the Code YouTube channel. There's a lot of fun projects on there, and definitely, if you're a new designer who's watching the podcast right now, listen to folks like Bill. They've got tons of experience, and I love that you're willing to share your knowledge, Bill, and really help new designers get into electronics and just have fun doing it. So thank you again for joining us.
Yeah, thank you. Thank you for having me. It was a pleasure.
And to everyone out there listening or watching on YouTube, make sure to like the video, subscribe to the channel if you want to see more podcasts. Go check out the links in the show notes, and definitely go watch Taste the Code. And tune in next time. Don't stop learning and stay on track.